Hi, so this is Zachary Whitlock with Engineering 267 and 2020 winter term. This is my projectile motion application made in Matlab. So if I open it up here, a little bit bigger and easier to see. Right off the bat we have some default values set in, so I can just hit plot and you can see plot a projectile right there. I can enable a range and it will plot a range around it. I have a zoom extents button to show, different angles set by the range, because it won't automatically zoom in on them. I can change the range, make a really big one, up to 90 degrees, and again, zoom extents. I can clear it and replot it. You can kind of see all the different plots it'll make. I can disable that range, of course, and just plot that normally. I can increase the initial velocity. See, the new line remains colored and the old line gets darkened. The X and Y can get set, so just like 10 and 10. Plot that, and the initial point up there is plotted, and the location is also put in the GUI here. And that will work for just about any value with X scaling, so you can kind of see how it kind of gets squished as it goes to the right. But it will show it. And of course the initial velocity can get changed, initial angle can get changed, and we can do all sorts of stuff like that. And it'll also show the distance in the x-axis that the projectile travels and the flight time of the projectile. Yeah, and so the code of it is in here. It's in the plot button event, the clear button event, and the zoom extents button event. As you can see, the plot button does most of the work. I do a little bit of error checking just to try to eliminate some random values in the range. I use 9.81 as the gravitational constant, so this entire thing is in seconds and meters, so such as meters per second squared and meters per second. This is the main work function. It actually calculates the y values out given some x input, so it calculates time given an x input and finds the y velocity and y output given an x value. And of course we like degrees because they're easier, so the inputs are given in degrees and then changed to radians. The x value is calculated given a function from Wikipedia. The peak of motion is also calculated given a function from Wikipedia, and the components of the velocity are just simply calculated from basic trigonometry. This right here, just as it says, sets all previous lines smaller. So like when you plot a new line, it will make it obvious which one's the new one. This is the secondary main part of the program. It actually uses that function that was declared earlier and sets the new line to have a line width of 2, so it's obvious what it is. This calculates the flight time. This will actually plot that point using an equation to find the time. This is actually the time of the peak, which is the initial velocity of y, divided by gravity. That'll find when the gravity cancels out the initial value of the y velocity. Anyway, the y velocity will be 0, and then it'll give the time of the peak, and you can just multiply that by the initial x velocity since we're not taking into account air drag. And the rest of this is just plotting that point. And then this is the range of values right here. You can see it just checks if it's range enabled. It recalculates all of the things it needs to graph some lines. Of course, it makes sure that it's holding on the lines, and it plots them with a darker or a grayish green color. And of course, there's some pause there, so that you can actually observe it happening. So yeah, that's the program. Thanks for watching. Remember, this is for Engineering 267. Thank you, and goodbye.